Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. This is Sanjay Rathi and we are discussing questions from standard textbook, that is Fundamentals of Electrical Circuit by Alexander and Sadiko. Okay guys, and this is chapter 10. Here I am going to discuss questions from Steady State Analysis of Sinusoidal Signal. Okay, then guys, I'm going to start the session, but let me know that everything is fine. I think now, okay. Then here from book you have to cover what? 3 chapters that is related to this one, that is the 9th chapter, then 10th one, and then what? 11th chapter. They are related, means it is related to what? Steady state analysis of sinusoidal signal. So I am going to discuss questions from chapter number 9 and chapter number 10. I think now you have book like Alexander and Sadiko. Wow, give me 1 minute guys. This is book Alexander and Sadiko and this is hard copy and I am going to solve some questions from this book. Okay, Praveen Pawar, how are you? So this is a, please open 10th chapter if you have book, otherwise use your copy, pen and calculator to solve some important interesting questions. Again we will solve some objective also, right? So this is a series to cover the question from standard textbook. After that I will start solving question from Cedra and Smith. Okay, so this is my introduction. Myself Sanjay Rathi, I am an ex-IES and I am having 23 years of teaching experience, and during this period I have mentored more than 1 lakh students for these competitive exams. I have qualified and selected for engineering services exam and these are my ranks, right? Now because of these ranks and because of my experience, I am going to take one important session, 1 year strategy for engineering services exam 2025. If you are interested for that, then subscribe the channel, stay tuned with me, because the timing of this session is what? 11:15 PM today. Okay, तो याद रखिए रात में हम half an hour में discuss करेंगे 1 year plan for engineering services exam. Okay, complete strategy about engineering services. Then guys, before starting the session, I want to share one important information with you. First, this is my Telegram channel, Electronics by Sanjay Rathi. I will upload the PDF. Already I have uploaded the PDF of what previous session, that is what chapter number 8. Right? I think you have gone through that. Shreyas, सबको मिल गया वो PDF on my Telegram channel, that is Electronics by Sanjay Rathi. And then that is for daily dose to improve the concept, daily important questions, latest information about the exam, notification of the class. And we are going to conduct one mock test for BEL exam, that is Bharat Electronics Limited, this Sunday at 11 AM. Then this is scholarship test, national scholarship test. You can avail what? 90% off on our program. Register now. Please note that date, that is the 5th of November, 9 AM to what? 9 PM. And then guys, this is workshop, free workshop by Joseph Singh sir at 7:30 PM on 8th of November. Roadmap to secure AIR under 100 in GATE 2025. That is what? 1 year plan. If you want to start your preparation for GATE 2025, then first of all install BYJU'S exam prep app and then join this workshop. Link is given in description on 8th of November. Then already I have given ESC 2025 1 year ESC preparation strategy in detail at 11:15 PM. Today. Okay. So now this is the first question. Okay, tell me what is the answer for this one guys. What is the answer for this question? Which of the following is not a right way to express the sinusoid A cos omega t? First of all, I just for warm up, because in sinusoidal signal we have to convert the sinusoidal signal into what? Phasor, and then we have to solve some questions, some basic questions. Again, these are the questions from Alexander and Sadiko, review questions, objective questions. First from 9th chapter, then from 10th chapter we will discuss. Okay, tell me which answer is correct for this particular question. Which of the following is not a right way to express the sinusoid A cos omega t? This is a periodic signal. So what is the omega here? 2 pi f. So omega is nothing but 2 pi f. And what is the f? 1 by t. So that is nothing but 2 pi by t. So guys, this is the 2, omega is replaced by 2 pi f t. So this is correct. A cos of omega can be replaced by 2 pi by t. That is also correct. Then it is a periodic signal. It will repeat by what? 2 pi. That is also correct. But what is this? A sine of omega t minus 90 degree. That is wrong. Because when we are putting the A sine of omega t minus 90 degree, it will become minus of A cos of omega t. Right? So what is the correct one? A sine of omega t plus 90 degree. That is the correct answer. Means what is the answer for this question? D. Answer for this question is what? D. This is not the correct representation. Okay. Second, quickly give the answer. Quickly give me the answer for all these questions, guys. Then, if V1 is equal to 30 sine of omega t plus 10 degree and V2 is equal to 20 sine of omega t plus 50 degree, which of these statements are true? Which of these statements are true? V1 leads V2. Very simple question, guys. V1 leads V2, V2 leads V1, V2 lags V1, V1 lags V2. V1 and V2 are in phase. Are in phase. Which answer is correct for this question? My MSQ. It is just like a MSQ, guys. It is just like a MSQ. Multiple select question. More than one answer may be correct. So remember, tell me what is the answer quickly. Then we will solve some important numericals on this. Okay. Then there are two options are correct. 30 sine of omega t plus 10 degree and 20 sine of omega t plus 50 degree. Then watch this. You can draw a line. Always remember this. This is, normally we are representing cos omega t and that is the 0 degree. In anti-clockwise, this is 90 degree. This is 180 degree. And in a clockwise direction, it is negative minus 90 degree and minus 180 degree. In a clockwise direction negative, in anti-clockwise direction it is positive. Now this is sine omega t. Total phase shift is 180 degree, so that is minus sine omega t. And that is minus cos of omega t. Remember this. Now what is written here? Sine of omega t plus 10 degree. Sine of omega t plus 10 degree. Then in phasor you can represent it by this one. 10 degree. 10 degree positive means it will in an anti-clockwise direction. This is the 10 degree. So this is the phasor 10 degree. Then second one is 20 sine of omega t plus 50 degree. So 50 degree means that is the 50 degree. Omega t plus 50 degree. This is the V2. This is the V1. So V2 leads V1. V2 leads V1 by 40 degree. Or you can say V1 lags V2 by 40 degree. Both are correct. Very simple. Both are correct. And that's why, which answer is correct? 1 minute. V2 leads V1, V1 lags V2. Both are correct. Okay. Now, so this is a very simple MSQ. Basic idea. 1 mark question in bail exam similarly, but in bail only one answer may be correct. Then, this is the question. Now, the voltage across an inductor leads the current through it by 90 degree. It is right statement or wrong statement? Quickly give me the answer. Voltage across an inductor leads the current through it by 90 degree. True or false? This is I. Now, true, you are saying that true. Voltage across an inductor leads the current through it by 90 degree. Yes, voltage lead, current lags. Why? Because ZL is equal to J omega L, and let this is the V, phasor angle 0 degree. So what is the I is equal to V 0 degree upon J omega L, means omega L 90 degree plus 90 degree. It will become V by omega L angle minus 90 degree, means current lags V by 90 degree, means voltage lead I by 90 degree. True. It is true. Okay. Very good answer. Shreyans, please check your answer. I think that explanation is clear to you. Now simply, what is the voltage across the inductor? ZL into I. So J omega L into I. So you will get the extra 90 degree. Omega L I 90 degree. It will lead by 90 degree. Okay then. The imaginary part of impedance is called, quickly within 30 seconds. Again, these are the questions. Just why I am going to discuss all this. Go through the review question first of all. So in a review question, you will get around 10 questions. In every chapter, there are 10 questions. And through those 10 questions, you can expect what 1 mark question, or sometimes it is 2 mark question, MSQ. So the imaginary part of the impedance is called, for example, this is the impedance, then R plus JX. This is represented as normally R plus JX. This is real part. Real part is called resistive part. Resistive part. And imaginary part is called what? Reactance. Imaginary part is called reactance, E. Right? So that is the E answer. And second thing, if it is a admittance, admittance means Y. Admittance means what? Y, G plus JB. So what is the G? Conductance. Conductance. And what is the B? Susceptance. What is the B? Susceptance. So this is the B is the susceptance. Okay. So that is for admittance and that is for impedance. Now, at what frequency will the output V0 in the figure 9.39 be equal to the input voltage VT? At what frequency output voltage is equal to what? Input voltage. At what frequency will the output voltage is equal to the input voltage? Exactly replica of the input. And this is the question on what? Filter, guys. Question on filter, high pass filter, low pass filter. So tell me, it is which type of filter also? High pass or low pass or band pass filter? Everyone, tell me guys, what is the answer for this question? Yes, please. For a basic idea, because in normally students are not comfortable with the sinusoidal signal, then first of all solve the basic questions. So I think now what is the answer for this one? At what frequency will the output voltage V0 T be equal to the input voltage? When the V0 T is equal to the input voltage, means there is no drop across the 1 ohm resistor. When there is no drop across the 1 ohm resistor, means what? It will act as what? Open circuit. So when it will act as open circuit, so open circuit, where it will act as open circuit, guys? Where the inductor will act as open circuit? At a 0 frequency or at infinite frequency? Because the impedance because of the ZL is J omega L, SL, J omega L. So what is the magnitude? Omega L. So you are giving the answer A. So you are saying that 0 radian. So at 0 radian, inductor will act as short circuit. The output will be 0. At 0 radian, that will inductor will act as short circuit, guys. And then what is the output? 0. And it will not pass the low frequency signal. It will not pass the low frequency signal. It will pass the high frequency signal. At infinity, it will act as open circuit. When it is open circuit, output is exactly replica of the input. So at infinity, at 0, and that's why it is a high pass filter. It will pass the high frequency signal, block the low frequency signal, and that's why the answer is D. D for Delhi. D for Delhi. So very basic question. Are you getting my point, everyone? Tell me. With these 10 questions, we are getting basic idea about the sinusoidal or steady state analysis. So these are the review questions just after every chapter. Okay. Then next one, 9.8. Now series RC circuit. Series RC circuit has VR. The magnitude of VR 12 volt, magnitude of VC 5 volt. The magnitude of the supply voltage is. So series RC circuit is not given. You can draw the circuit. This is the supply voltage. This is R. This is C. Voltage across the C, it is given as magnitude 5 volt. Voltage across the R, it is given as magnitude 12 volt. So magnitude 12 volt, 5 volt, and what is the magnitude of the supply voltage? So magnitude of the supply voltage. Tell me, श्रेयांश, है ना? एंजॉय कर रहे हो? तो चलो थोड़ा थोड़ा बेसिक आइडिया लगे, देखो कैसी छोटी छोटी मिस्टेक्स होती हैं. Okay, what is the answer? What is the answer? You can apply the KVL. So VR is given, VC, the magnitude of VC is given, series RC circuit is given, and what is the value of the magnitude of the supply voltage, it is asked. Now, everyone like the session also that, for example, VR is given, VC is given. In a series, we are having the same current. Same current will pass here through the VR as well as C. Then, this current and this VR in the same phase, but current will leads the voltage by 90 degree. In case of capacitor, current will lead the voltage by 90 degree. Then simply always remember, if this is the VR, then this is in the phase with what? I. And what about the, this is I. Then what is the VC? Lags the current by 90 degree. So what is the parallelogram? Means what? This is the VC is given as 5 and VR is given as 13. VR is 12. Okay, 12 and 5. This is 12 and this is 5. Where is the resultant? Resultant is this one. Voltage lags the current by 90 degree. But that angle, not 90 degree, that angle. VC lags the I by 90 degree. Then what is the resultant? You can find the VS, the magnitude of VS is nothing but root over VR square plus VC square. 12 square plus 5 square, that is root over 169. What is the 169? 13. 13 is the answer, not 17. 17, it is not just like a register, guys. In register, all are in phase. Remember, in a register, all are in phase. That's why we are adding. This is the 12 volt, this is the 5 volt. What is the total voltage? 17 volt. Right? This is the 17 volt. But it is a one resistor and one capacitor. You have to find the phasor sum. So what is the phasor sum here? This one. Phasor sum. And that is the resultant of what? VS. And VS lags I by what? This angle theta. And by using the trigonometry, you can find the theta. What is this? VC. And what is this? VR. So what is the, right? The tan theta is equal to, a theta is equal to what? Tan inverse of this height by base. So VC by VR. You can find the angle. VC by VR. But it is negative. Why it is negative? Because it is in an anti-clockwise direction. And voltage VS lags I. And that's why it is called leading circuit. Because current leads the voltage. Current leads the voltage. Okay. So these are the questions, objective questions. Last one. Okay, tell me from the ninth chapter, last question. Series RLC circuit has R is equal to 30 ohm. All other students try to give me the answer, guys. Everyone try to give me the answer. Series RLC circuit has R is equal to 30 ohm, X is equal to 50 ohm and XL is equal to 90 ohm. The impedance of the circuit is, again this is a very I think very easy question. Tell me guys, tell me which answer is correct. Which answer is correct? Now you can solve it. Series RLC circuit. What is the total impedance? J omega L, J minus J by omega C. So what is the total impedance? This is called JXL. What is the XL here? Omega L. Or this is called minus JXC. What is the XC? 1 by omega C. Minus JXC. XC is what? 1 by omega C. What is the XC is given? 50 ohm. Then the impedance will become R plus JXL minus JXC. Then R, what is the R? 30 plus J 90 minus J 50, and it will become 30 plus J 40. 30 plus J 40. So which answer is correct? Very simple one, B answer. Okay then. So these are the objective question, guys. Now which are objective we are getting this type of questions, then how we can solve this one? For example, it is numerical answer type question, or just we want to find the answer. Again, this is the numerical from what? Alexander and Sadiku. Find VT and IT, that is the figure number 9.16. Find VT and IT in the circuit shown in the figure. When we are saying that VT and IT, then VT is in a time domain, IT is in a time domain, and that is given 10 cos of 4t, 5.1 farad. Now, how we can find the VT? VT is the voltage across the capacitor and IT is the current through this circuit. Then first of all, we have to convert it into phasor. Phasor means what? Frequency domain. In a frequency domain, first this is the cos of omega t, 10 cos of omega t. So what is the value of the omega? 4 radian per second. Find the 4 radian per second. Then resistor will remain resistor 5 ohm. Capacitor is replaced by 1 by SC, that is 1 by j omega c for sinusoidal signal, or minus j by omega c. This is the impedance because of the resistor. That is given by minus j by 4 into 0.1. 0.1 means this has become 10 by 4 minus j 2.5 ohm. That is the impedance because of what? Capacitor, minus j by 2.5 ohm. And in a phasor, that is represented by 10 cos of 4t is represented by 10 angle of 0 degree. 10 angle of 0 degree. Okay. Then you can draw the phasor diagram or diagram in frequency domain. This is replaced by 10 angle of 0 degree. That is represented by impedance is minus j 2.5, and that is the 5 ohm. So what is the current here, guys? Current will become 10 voltage upon impedance, 5 plus 5 minus j 2.5. Now find the magnitude. Then in the denominator, everyone find the magnitude of this. That will become 5 square plus 2.5 square root of this. You will get the magnitude 5.59. 5.59 angle. Tan inverse of 2.5 by 5 with negative sign. 2.5 by 5 means 1 by 2. 26.56. 5.56. So it will become 10 divided by 5.59. Just I am giving you one example only. So I will become, this is the phasor current, I will become 1.79 approximately, angle will become 26.56. That is the value of I. That is the value of I, guys. 1.7, yes. Now I will give the answer, yes, plus or minus, that is the plus, na, Shreyans. Okay. Now in a time domain, how we can represent? In a time domain, the IT is represented by what is the magnitude here? 1.79. What was the reference cos? Omega t 4t. And what is the angle here? 26.56 plus 56. Means current leads the voltage. It is a leading circuit. Current leads the voltage by 26.56. Then what is the voltage across the capacitor? Now you can find the voltage across the capacitor is given by I ZC. What is the I here? 1.79 26.56. 1.79 26.56 degree into ZC. What is the ZC? 2.5. Because of J, angle is minus 90 degree. Angle is minus 90 degree. Then you can multiply into 2.5. You will get 4.47 angle. 90 minus 26.56. 63.44. Okay, this is the voltage across the capacitor in phasor. So what is the VT in time domain? 4.47 cos of reference is 4t minus 63.44. And that is the value in time domain. So anyone, this is clear to you? But just I have solved one question because so that you will get the idea. Very basic question. In exam hall, again it will take time, guys. In sinusoidal, when we want to solve, it will take some time for calculation. It requires some time, okay? So don't worry. But try to avoid what? Silly mistakes. Okay? So we have a number of questions. Try to practice some more questions, and that is the question number. And this is the answer 1.789, and that is the 63.43. So approximately you will get this answer. Any doubt? This is the answer in time domain. And what about this answer? These answers are in frequency domain. Pink one is in, that is what? In a frequency domain. This is also in frequency domain. That is the difference between time domain and frequency domain. Okay. Now, next question. Next, very, very simple one. You can expect this type of questions, 2-mark question. Then, similarly, quickly try to give me the answer for this question. Very fast. Determine the VT and IT. When we want to determine the VT, and this is the unsolved numerical. First watch this. What is the omega? Omega here 10 radian per second. Okay. What is the VM? 20. Angle 30 degree. So you can represent it as a 30 degree. Now remember, the reference is sine omega t. That is the sine of 20, and angle what? We have written sine 20 of 30 degree. Okay. This is the phasor, representation in phasor. 4 ohm will remain 4 ohm. Henry, 2.2 Henry. J omega L. So what is the omega? 10. So J 10 into 0.2. It will become J2. J2 ohm. That is converted into what? Frequency domain. Now, everyone give me the answer in comments box. Once it is converted into frequency domain, then directly you can write, what is the value here? 20. 20 angle of 30 degree. Then that is represented by J2 ohm. So directly what is the phasor I? It will become 20 30 degree divided by 4 plus J2. Now you can find what is the magnitude of that. Root 20, that is the directly you can say 4 square 16 plus 2 square 4, 20 root 20. That will become 4.47. 4.47 angle. Already we have solved 2 by 4, 1 by 2, 26.56. So no need to find every time. Shift 10 inverse of 0.5, 26.56. But this time it is positive. This is the value of the impedance. Now, what is the value of the current then? 20 divided by 4.47. 4.4742. Right, because that was the root 20. Actually, it is the root 20. So again, you will get the 20 divided by root 20 is 20. Angle will become 30 minus 26.56 and 3.44. Okay. Now, what is the difference between this one and that one? Guys, what is the reference here? Sine. So when we want to convert it into time domain, remember, what is the amplitude here? 4.47. Sine of omega. What was the omega? 10t. And what is the angle? 3.44. 3.44. That is the, you can write like this. So this is in time domain. Now when it is multiplied by the J2, so what is the voltage across the inductor? That is given by I into ZL. So I is 4.47. 3.44 into, what is this? J2. J2 means 2 angle of 90 degree. So it will become 4.47 into 2. 8.94. 93.44. That is the VL. So in a time domain, it is represented by 8.94 cos sine of 10t plus 93.44. 20 plus 93.44. So that is the answer for this particular question, guys. Easy? That is clear? If suppose it is given in the cos omega t, then again you can convert this answer in what? Cos. Cos also you can convert. Because remember, sine of omega t plus 90 degree is what? Cos. So you can convert it into cos. So this is the answer in time domain. This is the answer in time domain. This is the answer in frequency domain. And that is the answer in frequency domain. Okay. So this is when we are getting the output across the inductor, it is a high pass filter. It will pass the high frequency signal, block the low frequency signal. And RC circuit, it is a low pass filter. When we are taking output across the RC, it will pass the low frequency signal, but it will block the high frequency. For high frequency, capacitor will act as short circuit. So it is a low pass filter. Okay, RL and RC circuit. Then determine the V0 T in the circuit of figure 9.25. Again, if you want to find the V0, right? V0 T. So just it is a homework for you. Just I am giving you the hint. First of all, remember 20 cos of 4t. So what is the omega 4? This is represented by 20 cos of 15 degree. Sorry. In a frequency domain, it will become 20 angle of 15 degree. Reference is cos, omega is 4. Then this capacitor is replaced by minus j by omega c. And this inductor is replaced by j omega n. Omega you have idea, 4. So you can convert into this capacitor and that what? Inductor. And simply you can apply what? KCL here. V0 minus this upon 60, V0 minus 0 by that, V0 minus that. And then you have to arrange. This is a complex term. Then finally you can get the answer. So everyone please try to write the answer in comments box. What is the answer for this particular question, guys? And that is the question number, I think. 1 minute. Give me 1 minute. Question number 9.11. Okay. You can solve it. It will take time, but okay. no problem. Or what is the another method? You can find the parallel combination of these two. Once you have the parallel combination of these two, you can convert it into single impedance. Z. And this is the voltage. And then to find the voltage across this, you can apply the voltage division rule. Z upon R plus Z into what? Vs. Z upon R plus Z into what? Vs. So what is the Z? Parallel combination of j omega L minus j omega C. J omega C, and apply the voltage division rule. Okay. Then are you ready to solve some questions? So again, objective questions. So this is the sinusoidal signal. Now, before entering into the chapter 10, guys, this is for EC branch, all India open mega mock test on our app, that is BYJU'S exam prep. So first of all, install the BYJU'S exam prep app and then participate in this from 28th of October to 3rd November. So आज ही है, today 3rd November. So try to give the exam, register now. Link is given in description. And then guys, this is the schedule for electronics engineering. No doubt it is test for what all the branches, whether civil, mechanical, electronics, electrical and computer science. Participate in it. Get the idea about your preparation. Okay. And make proper strategy for remaining days. कितने दिन बचे हुए हैं? नवंबर, दिसंबर, जनवरी, 3 महीने के लिए अपनी तैयारी अच्छे से कर लीजिए. अब आता है भाई, देखो ऐसा क्वेश्चन आता है, find the Thevenin's equivalent of the circuit in figure as seen from the terminal AB. What is the Thevenin's impedance? But before solving this question, again watch this. This is a very lengthy one. That one dependent source is given. Already that diagram is in frequency domain because it is given J3 omega minus J4 omega. It is also given in what? Phasor notation, 15 angle of 0. Thevenin's equivalent means you can find VTH and RTH. This is the VTH and ZTH actually. Here you have to find the ZTH. It has real part or imaginary part both. That is the ZTH, Thevenin's impedance it is called. Thevenin's impedance and Thevenin's voltage here. Now, what is the Thevenin's voltage? Open circuit voltage. So what is the open circuit voltage you have to find? And what is the Thevenin's impedance? Because here we are having the dependent source. The same logic you have to apply. Which logic? You have to connect a 1 volt battery here, then I here, then you have to find the V by I, that will give you the value of the RTH. But you have to make it what? 0. You have to make it what? 0 means you have to take it what? Open circuit during solving the ZTH. But before solving this question, we will solve some objective. Then I will give the answer for that question. Okay. First, give me the answer for this one. Answer for this one. Quickly. The voltage V0 across the capacitor is. The voltage V0 across the capacitor is. 1 mark question. 1 mark question. So in a GATE exam, they will give you the question on steady state analysis of sinusoidal signal, but very basic question, guys. Okay. The voltage V0 across the capacitor in figure is. भाई देखो PDF है आप लोगों के पास, लेकिन बुक रेफर नहीं करना. आप अपने रफ कॉपी पेन कैलकुलेटर लीजिए और क्वेश्चन बनाइए जरा. आपके पास जो भी है, अगर हार्ड कॉपी अवेलेबल है तो हार्ड कॉपी यूज कीजिए, और अगर आपके पास सॉफ्ट कॉपी है तो सॉफ्ट कॉपी से बनाइए, लेकिन क्वेश्चन को सिलेक्टेड न्यूमेरिकल जरूर सॉल्व कीजिए. ओके. The voltage V0 across the capacitor in this. First of all, always remember that current will leads the voltage. This voltage. This current will leads the voltage, but this voltage will lag the current. So how we can find the V naught? Simply voltage division rule. What is the voltage division rule? V naught is equal to minus J1 upon 1 minus J1. Means that is the Z2, Z1. So according to voltage division rule, V naught will become Z2 upon Z1 plus Z2 into Vs. So here you can write V naught minus J1 upon 1 minus J1 into 10 angle of 0 degree. Okay. Then what is this magnitude 1 by root 2? It will become V naught is equal to 1 by, what is this, minus 90 degree into 10 angle of 0 degree upon, what is this, root 2. And angle is what? Minus 45. Angle is minus 45. Then it will become 10 by root 2. Okay. And then minus 45 plus 45, it will become minus 45. 10 by root 2 minus 45. Which answer is correct? Which answer is correct? Tell me. What is the 10 by root 2? 1 by root 2 is 0.707. Okay. B. Here minus 45 voltage lag. This voltage will lag this voltage. This is the answer. C is the answer. 7.071 minus 45. So this is minus 45 V naught according to voltage division rule. Okay. Okay. Next question. Next one. This is the answer is C. Any doubt? Then you can ask the value of the current I naught in the circuit of figure is. What is the value of the current I naught? I naught means you can use the current division rule. Current division rule means this is the Z1, this is the Z2. Simple current division rule you can use. This is the total current, phasor current I. And you have to find the current through the Z2. Then you can write Z1 upon Z1 plus Z2. Current division rule into IS. Z1 upon Z1 plus Z2 into IS. This is the IS. Then what is the Z1? J8. J8. What is the Z2 minus J2? IS 3. Then it will become J8 upon J6. J cancel. 8 by 6 means 4 by 3 into 3 angle of 0 degree. This is cancel out. What is this? 4 angle 0. So which answer is correct? Which answer is correct, guys? A. So don't worry about this question. Simply just we in normal case when it is resistor we are applying the what? Voltage current division rule. So same similar thing Z1 and Z2, that is called current division rule. Apply and you will get the option A. Option A. This is the current division rule. Okay. Next question. Next one. Now, what is the answer for this one? Using the nodal analysis, the value of V naught in the circuit of figure. We are getting this type of question, guys. Same type of questions, Thevenin's equivalent or what, superposition theorem. Normally we are getting this type of questions. Now tell me, using the nodal analysis, the value of V naught in the circuit of figure 10.45 is V naught. You can use the nodal analysis. Nodal analysis means what is the incoming current? This is the 490 degree. And then what is this? You can write incoming current is is equal to outgoing current V0 minus 0 by J6, V0 minus 0 by J3. Then this is, you can write 490 means J4 is equal to, this will become minus J V0 by 6, J multiply, so J square is minus 1, so minus J V0 by 6 plus this minus it will plus become plus J V0 upon 3. You can take J common, cancel out, then it will become 4 is equal to, you can take 6 as a LCM, V0, this is minus 1 plus 2. What about this J common, that is cancel out, then it will become 24 is equal to V0. Check my calculation. 24 volt. Is there any answer? D. 24 volt. Muhammad Sawan, you have given Suvan. No? Yes, you have given the right answer. Good. You have given the right answer. Okay. So that is very simple nodal analysis, and that is you will get the 24. So don't worry about the phasor or so on. Simply use the normal nodal analysis and how we can convert this complex number. That is a very simple calculation and you can find the values here. Okay. Then next question, 24 volt is the answer for this one. You can also find the parallel combination of J3 and minus J3 and then multiply with this. Again you will get the same answer. For example, what is the parallel combination of J6 and J3? So can you find? And then guys, multiplied with the 490, again you will get the same answer here. Then in the circuit of figure, the current IT is, what is the current IT? Current IT is 10 cos of omega t. 10 cos of omega t. And when we are having guys this one 1 Henry 1 Farad series RLC circuit. In the case of series RLC circuit, before solving the question, Mohammed, you are giving the answer 10 cos of t. Okay, why? Before solving the question, always check what is the resonance frequency here. So resonance frequency is given by 1 by root over LC. So what is the resonance frequency? Root over 1 into 1, that is the 1 radian per second. 1 radian per second. What is the 10 cos of omega t? So what is the omega here? 1. Means when the omega is 1, that circuit is under resonance. When the circuit is under resonance, then this combination will act as what? Short circuit. Under resonance, the combination of inductor and capacitor will act as, effectively they will act as what? Short circuit. Or directly you can say, what is this? J omega L. What is the omega 1? So it will become J1. What is this? Minus J by omega C. Omega is 1, C is 1, minus J. So what is the impedance? J1 minus J1, that is cancel out. So what is the total impedance? Because of these two, 0. And effectively they will act as what? Short circuit. Then what is the current here? Directly you can say IT will become 10 cos of omega t by 1. So that is the 10 cos of omega t. Circuit is under resonance. Okay, and we are getting the maximum current and minimum impedance. Maximum current and minimum impedance here. Okay, so always 10.4a, if this is the circuit it is given, first of all check for resonance. Normally we are getting circuit under resonance. Then refer to circuit in figure 10.47. This is the 10.47. Observe that the two sources do not have the same frequency. If if any particular, if in case, especially in case of steady state analysis of sinusoidal signal, if we are having the two sources with the different frequencies, two sources with what? Different frequencies, then which theorem is applicable? Tell me guys, which theorem is applicable? Okay. Then if we are having the signal with the different frequencies, for example, here omega is 2. Here the omega is 10. Omega is 2, omega is 10. Then guys, we can't solve it directly. Why? Because you have to find the impedance. What is the impedance? Because of the inductor J omega L. So which frequency we can use? Omega 1 or omega 2? Similarly for capacitor, what is the impedance? Minus J by omega C. Omega 1 or omega 2? And in that case, definitely we have to use the superposition theorem. No other options. To solve this type of questions, you have to use the superposition theorem, guys. So this is the 10.5 number question. And what you have to apply the superposition theorem. Are you getting my point? That is the method, right? So this is the not, and this is not applicable, this is not applicable, only the superposition theorem is applicable. Then how we can solve? You have to draw the two diagram for this. First, in first case, draw, make it short circuit. And then guys, replace this by J omega L. What is the omega here? 2 radian. And that is represented by minus J by omega C. This will act as short circuit. Then find the Ix. First of all, you will find the Ix in terms of what? Frequency domain. So that is represented by one angle of 0 degree. First, you will get the answer in what? Frequency domain. Then guys, in second case, suppose you are getting A angle of theta 1. For example, A angle of theta 1. Then you have to convert it into a time domain. So what is in time domain? It will become A, what was the reference? Sine of 2t plus theta 1. That is converted into time domain. First of all, convert it into time domain. Then second one, second case, make it short circuit, superposition theorem, it will become 0. What is the omega here? 10. Then that is written as one angle of 0 degree. This is the phasor I2 will become, and that is replaced by minus J by omega C. Here omega is 10, J omega L, here omega is 10. Then find the I2. Suppose you are getting the B angle of theta 2. Then convert it into time domain. First of all, P, what was the reference? Sine of 10t plus theta 2. Right? Then what is the complete answer? The complete answer is the summation of I1t and I2t. Then finally you can add in a time domain, so it will become A sine of 2t plus theta 1 plus B sine of 10t plus theta 2. I have not solved the theta 1 and theta 2, but just I have given you the method how to solve. We are getting very easy question on this diagram. You can solve it. And you can find the value of A, theta 1, value of B and theta 2 for this particular diagram. Means normally students are doing silly mistakes. What is the silly mistakes? They are adding the signal in what? Frequency domain. If suppose you are going to add the signal I1 theta 1 plus I2 theta 2, then you will get the I theta, then you want to convert. Then which one is the reference? Sine of 2t or sine of 10t? Then you will get the wrong answer. Then you will get the wrong answer. Means you have to find the answer in time domain I1t and I2t, then finally you have to add and you will get this result. That is the wrong method. For different frequency, it is wrong method. If suppose the frequencies are same, for example, this frequency and that frequency is same, we are having the two voltage sources. Again, you can apply the superposition theorem, then both method will work. Otherwise, first of all, find in time domain, then add. Then this one. For the circuit, the Thevenin's impedance at terminal AB is. Very, very simple diagram. For this type of questions we are getting, find the Thevenin's impedance only. 1 ohm, that values is given, impedance. When we want to find the Thevenin's impedance for this diagram, then first of all, make it 0. Thevenin's impedance means make it 0. And here it is Thevenin's impedance ZTH. Then, what is the omega here? 1. Omega, cos omega t meter, cos omega is 1 here. So that capacitor is represented by minus j by omega c. Omega is 1, c is 1, so it will become minus j1. It is j omega l. Omega is 1, l is 1, j1. Now these two are in parallel and that is in series. So what is the ZTH? J1 plus 1 parallel with what is the parallel combination? Multiplication of these two upon this one. Okay, then you can solve it. It's up to you. You can solve this. Then it will become minus minus plus this is cancel out. What is this? Root 2 angle of minus 45 degree. .707 angle of 45 degree. 0.5 plus 0.05. Okay, that is given. Yes, you can convert it. I have given in this form. You can convert in that form also. Okay. In that case, if this is the answer, this is the case, or this is the answer. 1 plus j1, 1 plus j1, it is multiplied. Then it will become 1 plus j1 upon what? 1 square plus 1 square, that is the 2. It will become 0.5 plus j 0.5. That is also correct. 0.5 plus j 0.5. Which answer is correct? C. So C you can find that simple question, guys. Simple questions on what? Thevenin's theorem 10.6 C. Okay. So this in this way we can solve. This is the C is the answer. Good one. Then for same diagram, what is the Thevenin's voltage? What is the Thevenin's voltage for this? Okay. When we want to find the Thevenin's voltage, so which answer is correct? Tell me. Option A, option B, option C, or option D. Thevenin's voltage means open circuit voltage. Open circuit voltage means here you have to find the Thevenin's voltage. So what is the current here? 0. You can drop the impedance, means you have to find the VTH across this. This impedance, this is what? 5 angle of 0 degree. That will become 1. Already we have find this is the J1. So according to voltage division rule, what is the VTH? Z2 upon Z1 plus Z2 into, right? Now it will become 5 angle of minus 90 degree because of this J minus 90 degree. And what is this? Root 2 angle of 45 degree. Then it will become 5 by root 2 angle of minus 45 degree. That is the VTH. Open circuit voltage. So that is what is the 5 by root 2. 0.353. 0.353, 3.53 minus 45. This is the Thevenin's voltage. Why we are finding the Thevenin's voltage? Just for maximum power, maximum average power transfer theorem, you have to find the Thevenin's VTH and ZTH. VTH and what? ZTH. So which answer is correct? No, 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 no. You are giving the D answer, but answer A is correct. Answer A. I am getting A. What is your, according to your calculation, which answer is correct? Praveen, Pawar, check your answer. That is a very, very simple one. Open circuit means what is the current through the inductor? 0. Then, next one. What is the Norton's equivalent impedance? Now, quickly give me the answer. 1 mark question only. Norton's equivalent impedance for this particular diagram. What is the Norton's equivalent impedance at terminal AB is? And watch the previous year question. You will get similar type of questions, easy questions from this topic. Easy questions from this topic. Okay, everyone. Refer to the circuit in figure. The Norton's equivalent impedance at terminals A and B is. Which one is correct? Mohammed, you are giving the answer A. Okay. Minus J4. Okay. Impedance, Norton's equivalent or Thevenin's impedance same. First of all, make it what? 0. And what is the Zn? Norton's means you have to convert into a one current source and one impedance parallel. Okay, across AB. So J and this are in parallel. You can multiply upon, add these two. What is it? J square minus 1 minus minus cancel, 8 divided by J2. Right? Multiplied with the J, divided by the J, it will become minus J4. Minus J4 ohm. A. Easy, Shreyans? All other students try to give the answer quickly. In complex number, normally what we are doing during exam, silly mistakes. When we are practicing more and more question, you can avoid this type of mistakes. Normally we are getting the very easy question. You can go through the previous year questions. Okay. Then, so this is the answer, minus J4. Now what is the Norton's current here? What is the Norton's current for the same diagram? The Norton's current at the terminal AB in the circuit of figure is. What is the Norton's current here? Then, to find the Norton's current, one angle of 0, same diagram now. Norton's current. Norton's current means short circuit current. To make it what? Short circuit. When I am making it short circuit, it will short circuit this impedance. That's why no need to consider it. So what is the current here? Same current will flow like this. So it will become ISC, that is nothing but Norton's current, is equal to 6 angle of 0 upon minus J2. And what is this? 6 minus J means it is minus 90 degree. That will become 6 by 2 means 3 angle of 90 degree. And what is the angle of 90 degree? J3. Three angle of 90 degree. So this is called Norton's current. Easy. These all are the very basic questions on what Thevenin's and Norton's and what superposition theorem. Okay. And if you want, then we can arrange one more session on the maximum average power transfer theorem, steady state analysis of sinusoidal signal, and what resonance, because we are getting question from what resonance, series resonance on what parallel resonance, guys. So we can practice questions. So this is the questions. Now 1 minute, just for your assignments I have solved. Just I want to give you the hint, because I have given you one question. 1 minute, that was the Thevenin's. But guys, remember, this is the calculation may be lengthy, but try to solve this question. Just I'm going to give you the hint. Find the Thevenin's equivalent. Thevenin's equivalent means you have to find the VTH and ZTH both for this diagram. Then how we can solve Thevenin's equivalent? Watch this. This is a MCQ question. They may give you answer, or just you have to find the answer. Then first of all, Thevenin's voltage. Suppose you want to find the Thevenin's voltage, then it is called open circuit voltage here. VOC. Here you have to find the VOC. Then how we can find the voltage? For example, this is actually it is a current source. It is an open circuit. It is an open circuit. Same current will flow here. 0.5 I0. 0.5 I0 will flow, because that is the open circuit. 0.5. This is the I0. So what is the total current here? 1.5 I0. And 1.5 I0 is equal to 15 angle of 0 degree. 1.5, this is I0, that is 1.5 I0, it will become 1.5 I0. 1.5 I0 is equal to 15. So what is the I0 is equal to 15 divided by 1.5, that is nothing but 10. 10 I0. This is the value of the current I0. Now, once you have the value of I0, then guys, you can apply the KVL from this loop to this loop. You can apply the KVL. So what is the, according to KVL, what is the VOC? Because it is in opposite direction, so this is the plus minus plus minus. So because of that, it will become negative 0.5 I0 into with minus sign. Why minus sign? Because we are moving in opposite direction. It will become 4 plus J3. Then this is the plus value I0, 2 minus J4. 2 minus J4. Then you can write 4 into 5, that is the minus 2 I0 minus 1.5 I0 plus 2 I0 minus J4 I0. Check my calculation also. Then guys, I think this 2 I0, this 2 I0 cancel out, and it will become 1.5, that is the 4, 2.5. Oh, sorry, 5.5. J 5.5 I0. J 5.5 I0. And what is the I0 here? 10. When you are writing the 10, it will become J 55 volt. Or you can write 55 angle of minus 90 degree. Is it answer? Mohammed, you are getting the same answer? Yes, tell me. I am getting this answer. I have not solved this question, just I am solving in front of you. So this is the question number, I think 10.25, figure number. Okay. Then that is the question from the 10th chapter. Easy one. Okay. And the answer is minus 55 minus of 90 degree. 55 minus of 90 degree. So easy. Directly you can apply the KVL. You can find a value. Very easy question. Then to find the RTH, then once you have the value of this angle, open circuit voltage, then you can find what short circuit current also. Why we are going to find a short circuit current? because what is the ZTH? ZTH is the open circuit voltage upon short circuit current. When I am making it short circuit, then same thing, same, but in this case, the current in this branch is not 1.5 I naught. It will become what? 0.5 I naught plus what? ISC. Plus what? ISC, and that voltage will become 0. Okay. Then you have to find a short circuit current. You have to apply the KCL at this point. 15 is equal to I naught plus 0.5 I naught plus ISC. And it will become 15 is equal to 1.5 I naught plus ISC. Okay. Then what is the relation between ISC and I naught? You can already we have applied the KVL. Then you have to apply what one? KCL. Already we have applied the KCL. You have to apply what? KVL here. KVL, and you will get the relation between I naught and ISC. Put here and you can find the value of ISC. VOC upon ISC will give you the value of ZTH. First method. Second method, you will get the answer. Just I am going to give you the hint for this question. And ZTH 4 minus J 0.667. Right, that is the answer. Okay, so directly apply the KVL. I can also apply this will become minus of 2 minus J4 into I naught. Move in the clockwise direction. 4 plus J3 multiplied with 0.5 I naught plus ISC, and okay, now is equal to 0. Get the relation between I naught and ISC. I naught in terms of ISC put here, and then get the value of ISC and then divide it, and that will give you the answer. This is one way to solve the question, guys. Or what is another way to solve the question? Is there is any other way to solve the question, guys? 1 volt battery we are connecting, yes or no? When we are connecting the 1 volt battery here, watch this. First of all, second method is remove this current source. Okay, open circuit. Then you can connect a current source also, and here you can find the voltage. Then it will become V by I. You have to find the V by I, guys. So this is the current I. It is nothing but this is the 0.5 I naught, this is the I naught. So what is the relation between that I and this 1.5 I naught? This is the 1 I naught and 1.5. This will become 1.5 I naught. Okay, and then you can apply a KVL from this point to this point. When we are applying the KVL from this point to this point, right? 1 minute. This is the I naught. So you can write a KVL 4 plus J3, and already you can add all these. 4 plus 2 6. J3 minus J4, it will become J1. Check my calculation. This is the I naught, and then this will become 6 minus J1 into I naught, and that is what V. Already I have applied the KVL from this point to this point. KVL, and already I have I is equal to what? 1.5 I naught. So what is the ZTH will become? V by I. So what is the V? 6 minus J1 I naught upon 1.5 I naught. Tell me, what is the 6 by 1.5? That is the 4 minus 1 by 1.5. 2 by 3. That is the 2 by 3 means what? 0.667. We are getting the answer, guys. Is it clear? Easy one. Which one is the easy? VOC upon ISC or direct? V by I. So you have to choose one extra current source I, and that is the voltage source V, and then get the relation V by I, and that is called what? ZTH. So guys, Thevenin's theorem on what? Steady state analysis of sinusoidal signal. This question is very, very important one. If you are able to solve this type of questions, you can solve any type of questions. Okay? Okay, then it will boost your confidence, guys. So now, already I have solved question from chapter number 9 and 10. If you want more question, then write in comments box. Next session on Monday, right, at same time 5 p.m. we will discuss question from two-port network. Again, Alexander and Sadiku, and after that I will start solving question from Sadra and Smith. You can install what BYJU'S exam prep app from Google Play Store. Try to give the quizzes there. You will get the idea about the leaderboard, how many students participated in the course, what is your rank, what is your strength, what is your weakness. Okay, so try to give the mock test. Free mock tests are available on Google Play Store. That is BYJU'S exam prep. And if you want to start your journey with us, then GATE 2024 we have crash course with this facility, live classes, recorded lecture, study material, practice quizzes, mock test. And if you want to start preparation for 25 and 26, then again you can join. This is for EAC and GATE, right? Complete syllabus coverage in English and Hindi, both. And these are the faculty members, guys. For more detail, you can call at this number. And at today at 11:15 p.m. I am going to take important session on EAC 2025 1-year EAC preparation strategy in detail. So you can join that session. Join my Telegram channel if you want the PDF of this, or if you want to clear some doubts, if you want to give some suggestion, then you can join my Telegram channel. You will get the notification about all my sessions here. Okay then, thank you for my side. Thank you very much for attending the session. Hope you are enjoying, Shreyans. तो ऐसे ही सॉल्व करते रहिए क्वेश्चंस फ्रॉम स्टैंडर्ड टेक्स्ट बुक. कुछ रिव्यू क्वेश्चन सॉल्व कीजिए, कुछ ऑब्जेक्टिव सॉल्व कीजिए, कुछ सॉल्व एग्जांपल सॉल्व कीजिए, कुछ अनसॉल्व सॉल्व कीजिए. जैसे भी कीजिए, कुछ क्वेश्चन सॉल्व कर लीजिए, ये आपका कॉन्फिडेंस इंक्रीज कर देगा. ओके देन, थैंक यू. लाइक द सेशन, शेयर द लिंक ऑफ दिस सेशन एंड सब्सक्राइब आवर चैनल.